Mijapko, and I'm trying to present the Vesper, and the project that we had is so my element was carbon disulfide, and it's also known as CS2. Is a colorless it's a colorless volatile liquid. This compound is used frequently as a building block in organic chemistry, which is like like the real chemistry, and has a lower structure of S, two S's and one C in the middle, and double bonds as we see. They're double bonds because they're both CNOPs, which is carbon, nitrogen, oxygen, phosphorus, and sulfur. When these exceptions are in an element, we can use more than a single bond because that here we have C and S, which means we have C and S in here too, so we can use double bond. And then the outermost shells will have four on them, and then four, and then it wouldn't have any lone pairs, so it's going to be a non-polar element. And then sulfur disulfide has a boiling point of 115.3 degree Fahrenheit and has melting point of negative 111.5 degrees Celsius. And it's also, as I said, a non-polar molecule. The first reason is because it doesn't have any lone pairs, and the other thing is was uh, it also has a molecular geometry shape of linear with a symmetric electrons on original distribution around the central atom. Okay, so this is the main presentation of my element, and then when we come to the physical states, there's physical states of matter. There are merely three: there's solid, liquid, and gas. And then solid has a definite shape and distinct boundaries and fixed volume, which means it has a definite shape, and then which means the distinct boundaries, like it only stays together for a lot of time. And then this least compressibility, it has the least compressibility, and it has a high density. And then liquid has a fixed volume and but not fixed shape, as we said right here. It has the fixed volume but not the fixed shape. But then the solid here has a fixed volume. That's the main difference between them. And then they have a higher compressibility. Liquid has a higher compressibility, and then it has also a low density one. This one has a high density. But then gas is not it doesn't have neither no fixed shape or nor fixed volume, which makes them different from both solids and liquids. Maybe one half part same as liquid because it doesn't have a fixed shape just like that. And then it has the highest compressibility. This mainly the same thing as this, and then it has low density as the liquid. The only difference is that liquid has a fixed volume and this one doesn't have a fixed volume, and they're spread out apart. In liquid, they're a little tighter, but then they have space in the middle that gives some air, and then here it's all tight and you can't even make a space on it. Okay, so now when we go to the phase diagrams of the main phase diagrams, so when we see this graph, it's mainly talking about the phase diagrams, and then this on the x on the y we have the pressure or the ATM, and then the x we have the temperature. So when we graph this, the graph is going to go like this and go up, and then this one continues like this, which ends at a critical point, which means the ending point. And then right here there's a normal boiling condition point, which there's a boiling happening in that condition. And then right here there's a normal melting point, and then here is the liquid spot, and then here's a gas here, and then right here there's this triple point, and then the triple point, which is the 3 points that changed it to and then here there's a solid molecules, and then the liquid molecules are like right there in the point. And then so the phase diagrams are mainly based on the graph, so, and the elements. Yes.